In this tutorial, we are going to continue with another application in order to simplify an expression into separate terms of x power n, where n is a real number. For this purpose, we are going now to set of exercises 8D, exercise number 3, part J. Find the following integrals. We have in part J square root of x multiplied by the square root of x plus 3 all squared with respect to dx. Then the term inside the integral is a little bit complicated, so we have to work it out so it becomes more easy and better for integration. Let's do it in the form of linear combination. Let's take the square root of x multiplied by the square root of x plus 3 squared. Let's take the bracket and expand it. So we have now to expand the square root of x plus 3 all squared. This is equal to the square root of x plus 3 multiplied by the square root of x plus 3. Let's split the terms in the first bracket. Then it's the square root of x multiplied by the square root of x plus 3 plus 3 multiplied by the square root of x plus 3. This is equal to, let's expand now, square root of x multiplied by the square root of x is x, plus the square root of x multiplied by 3 is 3 square root of x, plus 3 multiplied by the square root of x, plus 3 multiplied by 3 is 9. This is equal to x plus 3 square root of x plus 3 square root of x is 6 square root of x, plus 9. So now this can be written as the square root of x multiplied by x plus 6 square root of x plus 9. Now we can proceed with expanding these two terms. The square root of x multiplied by x is x into the square root of x, plus the square root of x multiplied by 6 square root of x is 6x, plus 9 square root of x. Now we can take both x multiplied by the square root of x and 9 multiplied by the square root of x and take square root of x as in common. So it becomes, or we can rewrite it in the power form, x into x to the power half plus 6x plus 9. Instead of writing square root of x, we write x to the power half. So using the indices rule, we can say x multiplied by square root of x is equal to x power 3 over 2 plus 6x plus 9x to the power half. Now we have the original expression that comes after integration changed or written in the linear combination form. So we can now integrate x to the power 3 over 2 plus 6x plus 9x to the power half, all with respect to the x. So now we can do each term separately. Let's take the first term, so it becomes x to the power 3 over 2, 3 over 2 minus or plus 1 is 5 over 2, all divided by n plus 1, that is 5 over 2, plus 6x, x is to the power 1, n plus 1 is 2 divided by 2, plus 9x to the power half, half plus 1, which is n plus 1, then it's 3 over 2, all divided by n plus 1, that is 3 over 2, plus c, the constant. This is equal now. We take the denominator and write it in the reciprocal form. So it's 2 over 5 multiplied by x to the power 5 over 2 plus 6 divided by 2 is 3 multiplied by x to the power 2 plus 9 multiplied by the reciprocal of the denominator, that is 2 over 3 multiplied by x to the power 3 over 2 plus the constant c. This is equal to 2 over 5 multiplied by x to the power 5 over 2 plus 3x squared plus 9 divided by 3 is 3. 3 multiplied by 2 is 6 multiplied by x to the power 3 over 2 plus the constant c. As you can observe, in order to be able to integrate this expression, we did expand twice the expression, then we worked with indices.